Now let's look at finding truth tables for compound statements. So we have one up here, P exclusive or not Q and R. But first of all, we've got to find all the different combinations of P, Q and R. So we could start with all of them being true. Then if P stays true, Q could be true and R false. Or Q could be false and R true. Or they could both be false. So that's all the combinations if P is true. And if P is false, you're going to get a similar set of combinations for Q and R. They could be both true, Q true, R false, Q false, R true, or both Q and R false. And if you look at these, you can see that under the P column, you get 4 trues in a row and then 4 falses in a row. In the Q column, you get 2 trues, 2 falses, 2 trues, 2 falses. And in the R column, it's true, false, true, false, true, false, all the way down. So if you remember that pattern, it's easy to remember the setup. The next thing I do is I look at my compound statement and say, are there any negations? And in this case, there is one, because we've got not Q. So I'm going to put a column in for not Q. Then I look at the brackets. So there's a bracket which is P exclusive or R, and a bracket which is not Q and R, and then finally the final statement. So what we're doing is we're breaking it down step by step. Sorry, I put an A in there, not a... So breaking it down step by step until we can come up with a truth table for the final statement. So looking at not Q first, that's always the opposite of what Q is. So if Q is true, not Q is going to be false. Q true, not Q false. Q false, not Q true, true. Now Q is true again, so we've got 2 falses. And Q is false again, so we've got 2 trues. Now looking at this column, this is P exclusive or R. So we're only looking at these 2 columns, P and R. And this is only true if one is true or the other, but not both. So there has to be one and only one true. So in the first line, there's 2 trues, so that's false. Second line, P is true, R is false, so there's only one. Third line, P is true, R is true, so that's false, because there can only be one. P true, R false, so there's only one true. P false, R true, only one there. P false, R false, there aren't any trues, so that's false. P false, R true, so that's true. And they're both false, so that's false. Now the next column we're looking at is not Q and R. So now we're looking at these 2 columns. And because it's an and, this is only true if they are both true. So in the first line, first row, because not Q is false, this is false. Second line, they're both false, so this is false. Third row, they're both true, so this is true. One true, one false. They need to both be true. One true, one false. Both false. Both true, so this is true. And then one true, one false, so this is false. So just double check that I haven't mixed up my columns. Yep. And now we can look at these two columns, which are our two brackets, to find the final one. Now, because this symbol is an or, it's either the first bracket or the second bracket or both. So if there's any true at all in the line, then this is true. However, the first row, they're both false, so that's false. We have a true in this one because the first bracket is true. Here the second bracket's true, first bracket's true, first bracket's true. Neither's true, so this is false. They're both true, but because this is just an ordinary or disjunction, that's true, and then they're both false, so that's false. So here we have the completed truth table for this compound statement.